AI broke the internet again, and this week has been absolutely insane. OpenAI announces GPT 5.6, their most capable model yet. And then, the very same day, the US government quietly asks them to not actually release it to the public. Alibaba drops HappyHorse 1.1, the upgraded video model, now stepping into the gap left by Sora shutting down and Seedance getting frozen by Hollywood. A new open source model called Ornith 1.0 claims to beat Claude Opus 4.7 on coding benchmarks, while running as a tiny 9 billion parameter model on your local device. Wan drops a model that can listen, see, speak, and respond in video, all inside a single transformer at under 600 milliseconds latency. Nvidia releases a training-free framework that speeds up any video diffusion model up to 10 times without changing a single weight. We have a new open-source robot brain that gives mobile manipulation robots a persistent 4D memory of their environment. FineVLA releases the largest open, fine-grained robot action dataset we've seen yet, and a lot more. So let's jump right in. First up, OpenAI announces GPT 5.6, and this is actually a 3-model family with Sol, Terra, and Luna. Now, Sol is the flagship. It's the most capable model OpenAI has ever released, designed for the hardest tasks: complex reasoning, long horizon coding sessions, agentic workflows, and security research. Terra is the mid-tier option, positioned as matching GPT 5.5 class performance at roughly half the cost. And Luna is the fastest and cheapest, designed for summarization, drafting, and high-volume routine automation. Now, here are the actual benchmark numbers. On Terminal Bench 2.1, which tests real command line coding workflows that require planning, iteration, and tool coordination, Sol sets a new state-of-the-art. In biology, Sol and Terra both outperform GPT 5.5 and GPT 5.4 on GeneBench v1 and manage those stronger results while actually using fewer output tokens. The cybersecurity performance is what makes this launch genuinely notable and also complicated. GPT 5.6 Sol scored 96.7% on OpenAI's internal capture the flag cybersecurity evaluations. That crossed what the company classifies as a high cyber risk threshold under their preparedness framework, which is actually the first time a full model family has crossed that threshold, including the smaller, faster Luna and Terra tiers, not just the flagship. On Exploit Bench, Sol is competitive with Anthropic's Mythos Preview, while using only about 1/3 of the output tokens. On Exploit Gym, a benchmark developed by UC Berkeley alongside OpenAI and other frontier labs, all 3 GPT 5.6 models show strong improvements in cyber capability as reasoning time increases. Now, Sol also introduces 2 new modes: a new max reasoning effort that gives the model more time to think deeply on complex tasks, and a new ultra mode that goes beyond single agent limits by spinning up subagents to tackle sophisticated workflows in parallel. Pricing for Sol is $5 per million input tokens and $30 per million output. Terra is $2.50 in and $15 out. Luna is $1 in and $6 out. OpenAI also invested over 700,000 A100 equivalent GPU hours in automated red teaming before release, and the safety stack now includes real-time activation classifiers, account-level conversation monitoring, and behavior pattern detection across sessions. They're clear that Sol remains optimized for defensive containment. It can find and fix vulnerabilities. Now, I will note that all of these numbers are OpenAI's own evaluations, not independent third-party benchmarks. Now, here's where things get very interesting. The same day OpenAI announced GPT 5.6, the US government asked them to delay the public rollout. Specifically, the White House Office of the National Cyber Director and the Office of Science and Technology Policy contacted OpenAI before launch and asked them to limit initial access to a small group of roughly 20 government-approved trusted partners. So right now, if you're not in that approved partner list, you cannot access GPT 5.6 at all. There's no public waitlist, there's no self-service enrollment. This is actually the first practical application of a Trump administration executive order from June 2nd, 2026, which called on federal agencies to benchmark and assess new AI models with advanced cyber capabilities before broad release. Now, OpenAI says they're not happy about this becoming the default. Sam Altman posted on X that the government requested a limited preview instead of the broader launch they had planned. And the company explicitly said they do not believe this kind of government access process should become the long-term standard. But they complied anyway. This is also happening in the context of the U.S. government's export control action against Anthropic's Fable 5 model earlier this month, which resulted in Anthropic pulling that model entirely. So the broader picture is that the U.S. government is now actively intervening in how frontier AI models reach the market in ways that have real consequences. Whether you think that's appropriate or not, it's a genuinely new dynamic. And it's worth watching how the August framework deadline actually plays out. If you're interested in reading further, I'll link to this page in the description below. Also this week, Alibaba drops a pretty significant video model update. It's called HappyHorse 1.1, and this is the enterprise upgrade to Alibaba's AI video generation model. Now, if you've been following AI video this year, you know this release is landing at a very specific moment. OpenAI shut Sora down on April 26th because the economics of running large video generation at consumer scale just didn't work. And ByteDance froze the international rollout of Seedance 2.0 in March after Hollywood studios, including Disney, Warner Brothers, and Paramount, sent cease and desist letters over copyright infringement concerns. So in a matter of roughly 90 days, two of the most credible enterprise AI video options exited the international market. And HappyHorse 1.1 is stepping directly into that gap. Now, for your reference, HappyHorse 1.0 already holds the number 2 position on Arena AI's Video Arena leaderboards with an ELO score of 1,444 in both text-to-video and image-to-video. That puts it 69 points ahead of Google's Veo 3.1 in text-to-video and 23 points ahead of xAI's Grok Imagine Video in image-to-video. In an ELO system, persistent double-digit leads reflect consistent quality differences from real human preference votes, not a statistical fluke. So what's actually new in 1.1? 3 things. First, multi-image reference to video is now supported up to 9 reference images simultaneously. Most competing models max out at 1. For brand, product, or character consistency across a series of clips, that's actually a really meaningful upgrade. Second, native audio generation is now fully activated in the production API. The architecture was always designed for joint audio-video generation, meaning text, image, video, and audio tokens all run through a single 15 billion parameter transformer at the same time. Version 1.0 had this architecture, but audio wasn't surfaced in the API. 1.1 turns it on, with native synchronized audio generated alongside the video in a single pass rather than a separate dubbing step. It also ships with multilingual lip sync across 7 languages out of the box. Third, motion dynamics, subject consistency, and instruction following all received targeted upgrades, specifically addressing the issues users flagged most with 1.0: stiff motion, face drift across frames, and prompts getting partially ignored. Now, one flag worth noting: if you need open weights or local inference, this isn't your option. HappyHorse is an API-first hosted product. The open weights leaders for video right now are still WAN 2.2, Hunyuan Video, and LTX2. HappyHorse's advantage is quality and speed via API, not open access. The launch also comes with a 40% API discount for the first 2 weeks. And Alibaba has EU-compliant deployment options now live through their Paris data centers as part of their $52.7 billion global infrastructure build-out. If you're interested in reading further, I'll link to this page in the description below. Next up, we have a really impressive new open source coding model family. It's called Ornith 1.0, and this is a self-improving family of agentic coding models from Deep Reinforce that comes in 4 sizes: 9 billion dense, 31 billion dense, 35 billion MOE, and 397 billion MOE. Now, the key innovation behind Ornith 1.0 is what they call self-scaffolding. So how this works is most training frameworks for coding agents use a fixed human-designed harness to structure the agent's problem-solving approach. Ornith 1.0 instead learns to generate both the solution and the harness that guides the solution simultaneously. The model jointly optimizes the scaffold and the resulting answer, and then uses the feedback from the solution's reward to improve the scaffold too. In other words, the training process itself keeps getting better because the model is also learning how to set up better tests for itself. Now here's where things get interesting. The flagship Ornith 1.0 is outperforming some of the biggest closed models on major coding benchmarks. It scores higher than Claude Opus 4.7, Minimax M3, and DeepSeek V4 Pro on both Terminal Bench 2.1 and SWE Bench Verified. That's actually pretty remarkable for an open source model. But here's what I find even more interesting. The 35 billion MOE version scores 64.4 on Terminal Bench 2.1. That's actually higher than the full 397 billion Quen model, which only scores 53.5 on the same benchmark. And the tiny 9 billion dense version, 9B version, scores 43.1 on Terminal Bench and 69.4 on SWE Bench Verified. Despite being just 9 billion parameters, it matches or beats Gemma 431 billion on both benchmarks. Now that last one is the one that matters most for your GPU. The 9 billion model can be deployed on edge devices with pretty standard consumer hardware. The awesome thing is they've released all 4 models already on Hugging Face under an open license. The 9B and 31B dense models are especially worth checking out if you want to run a genuinely competitive coding agent locally. If you're interested in reading further, I'll link to this page in the description below. Also this week, we have a pretty impressive new real-time interaction model. It's called WAN-Streamer v0.1, and this is a native streaming end-to-end model that can listen, see, think, speak, and respond in video, all inside a single transformer, in real time at 25 frames per second. Now, most real-time AI interaction systems right now are speech only. They produce fast audio responses, but no synchronized face or body. And the ones that do produce an avatar are usually stitched together from separate ASR, language model, TTS, and animation modules, which adds latency at every single boundary. WAN-Streamer does everything in one unified transformer. For your reference, here are the actual latency numbers. WAN-Streamer has a model-side response latency of just 200 milliseconds. With 350 milliseconds of bidirectional network latency added in, the total round-trip interaction latency is about 550 milliseconds. Now, how does that compare? GPT-4 O Realtime hits about 230 milliseconds model-side and around 800 milliseconds total, but it's speech only. Dubao Voice hits around 700 milliseconds model side and about 1 second total. Gemini Live ranges from 1.2 to 3.6 seconds, and the avatar-specific systems like LPM 1.0, Omniforcing, and HoloLive are only timing their rendering stage, which doesn't even count the external language model they depend on. OneStreamer is the only end-to-end model right now that produces synchronized audio plus video in a single forward pass and does it under 600 milliseconds total. Now, I'll be upfront. This is a v0.1 research release, and the demo quality is good, but not perfect. The video generation isn't at the level of a dedicated avatar system yet, but the architecture is genuinely novel, and the latency numbers are real. The paper is on Archive, and this is from the WAN team. If you're interested in reading further, I'll link to this page in the description below. Next up, Nvidia releases a pretty useful new tool for video generation. It's called Sol Video Inference Engine, and this is a training-free acceleration framework that can plug into any video diffusion model and speed up inference without changing the model weights at all. Now you see, the problem with video diffusion inference right now is that there are actually 5 different ways to make it faster: caching intermediate activations, sparse attention, token pruning, quantization, and kernel fusion. But tuning all 5 together for each different model and hardware combination requires deep expertise and a huge amount of manual effort. Sol Video Inference Engine solves this by being what they call agentic and native, meaning it has an agent that automatically selects the right combination of these 5 techniques for your specific model and hardware setup, without you having to manually tune anything. For your reference, here are the actual numbers. Sol achieves up to a 10 times speedup over baseline video diffusion inference. And on RTX 5090 GPUs using NVFP4 precision, it reduces the time to generate a 5-second 720p video from 71 seconds down to 29 seconds, a 2.4 times speedup on top of an already optimized model. The awesome thing is they've released this already as part of the NV Labs Sana repository on GitHub. The code is open source and works with any video diffusion model that uses standard diffusion transformer architectures, not just Sana. Note that to get the full 10 times speedup, you'll want high-end hardware. But even on more modest setups, the framework applies whatever subset of optimizations your GPU supports. If you're interested in reading further, I'll link to this page in the description below. Also this week, we have a really interesting new open framework for robot learning. It's called FineVLA, and this is a fully open framework that takes existing robot datasets and upgrades their instruction quality from vague goal-level descriptions into precise, step-by-step action supervision. Now, you see, the problem with most robot training data right now is the instructions are too coarse. A trajectory might be labeled something like, pick up the bottle, but it has no information about which arm to use, what approach direction to take, or where exactly to make contact. That gap between the instruction and the actual execution detail is one of the main reasons robot policies fail when conditions change slightly. So how this works is FineVLA takes 972,000 trajectories across 10 open robot datasets and runs them through a 4-stage pipeline that unifies the format, filters bad recordings, removes redundant examples, and then annotates each remaining trajectory with 10 dimensions of fine-grained instruction. Things like active arm, approach direction, contact region, and movement style, verified by humans. The output is a corpus called FineVLA data with 47,000 human-verified trajectories, where the average instruction length is 10 times longer and more specific than the original dataset labels. Now for your reference, here are the results. Training a VLA policy on fine-grained instructions versus raw goal-level labels gives improvements of plus 1.4 to plus 8.1 success rate points, even in tasks where the fine-grained instructions provide no new semantic information. The strongest mixed setting of fine-grained and raw instructions reaches 86.8 and 82.5% success in RoboTwin simulation, and 62.7 out of 100 in real-world dual-arm manipulation, compared with just 49.9 for raw-only training. The specific gains are largest exactly where goal-level instructions give no guidance. Pose control, plus 23 points. Color specificity, plus 18. Approach direction, plus 18. The awesome thing is they've released everything. All of it is on GitHub and Hugging Face. This is a joint project between Xlang Lab at HKU and the Quen team at Alibaba. If you're interested in reading further, I'll link to this page in the description below. And finally this week, we have a really cool new open source tool for robotics. It's called SERF, which stands for Spatiotemporal Environment and Robot Feature Map. And this gives a mobile manipulation robot a persistent 4D spatial memory of its environment so it can handle long horizon tasks without forgetting where things are. Now you see, most robot vision language action policies today are essentially amnesiac. They can only see what's in front of them right now. If an object moves out of the camera frame, or if the robot has to go to another room and come back, it has no memory of what it saw before. SERF solves this by building a live 4D map, not just of the environment, but also of the robot's own body, both represented in the same shared latent feature space. The map is built from neural points that learn to reconstruct dense dino embeddings, and it updates in real time as the robot moves. So the robot always knows where objects are, not just where they are right now, but where they were and how they've moved. Here are some examples. In their Behavior 1K evaluation, you can see SERF outperforming the PI 0.5 image-only baseline across tasks like collecting children's toys. The SERF robot follows more direct trajectories and reaches intermediate goals faster. And as you can see in the failure recovery demo, when an object is dropped and leaves camera view during transport, the SERF robot can relocalize and re-grasp it successfully, while the image-only baseline just keeps going. SERF also generalizes better to out-of-distribution scene configurations, meaning moved goal locations, extra objects in the scene, and objects placed in rooms the robot has never actually visited. Now, this won a Best Paper Award at the ICRA 2026 workshop on multimodal spatial AI. The VLA code and the mapping code are both on GitHub under Apache 2.0, and the paper is on Archive. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite, and which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.